Hello and good day to you. It's me again, Akpete Christopher, and I am a college student. And today I'm going to present to you why the data path has a big influence on the CPU. Once again, my name is Akpete Christopher. So, in today's presentation, we are going to dive deep into data cycle and how the CPU operates. Get ready to join me on this massive adventure. Now, there are many questions, and one question is what is the data cycle path? Well, you may be wondering what is the data cycle path and why it has such a big influence on the CPU. Well, the data cycle path refers to the time it takes for the CPU to travel through different components of the CPU while executing an instruction. This means that it is the time required to move around components of the CPU, such as the registers, the ALU, also known as the arithmetic and logic unit, and other components when decoding, executing, and storing instructions. We will delve deeper into this later in the video. Now, why is the data cycle so impactful to the CPU? The data path cycle is so impactful to the CPU because 1. The clock speed. This is a shorter data path cycle supports higher clock speed, hence increasing processing speed. And 2 is the instruction speed. This is because a shorter data path cycle allows faster execution of instructions. The third, we have the pipeline efficiency. Another reason why the data cycle is so impactful to the CPU is its pipeline efficiency, and this is shorter cycles reduce delays and bottlenecks in pipeline execution, further enhancing parallelism. Number 4, throughput. It enables more instructions to be processed per clock cycle, improving overall throughput. In conclusion, we can all admit that a shorter data path cycle means the CPU can process instructions faster. Now, how does the CPU fetches, decode, and execute instructions? Well, this process of the CPU is also known as the instruction cycle. And as we are now on this point of the topic, I would just like to give simple definitions for each of the instruction cycles so that as we go further into today's discussion, we will find it easier to understand the much more complicating stuff ahead. So before we dive deeper, let's learn what each instruction does. First, we have the fetch instruction. This is the first stage of the instruction cycle where instructions are received from the main memory before the CPU can execute an instruction. And we have the decode. This stage translates the received instructions into series of computer commands. Before a command can be executed, the control unit must decode the instruction into a form the ALU, which is the arithmetic logic unit, understands. Third, we have the execute instruction, where in this stage of the instruction cycle, the command is executed when the CPU carries out the instructions in order by converting them into macro codes. And finally we have the store instruction. In this stage of the instruction cycle, the results are written and stored back in memory. So overall, the process of the data cycle or the instruction cycle, which other people call it, their processes are the fetch, decode, execute, and store processes. These are simple definitions of the instruction cycle. Now, before we go further, This is where I need your attention the most. So let's get started. We've come to understanding the instruction cycle. Now don't get scared of the image because I'm going to take my time to explain to you what every single one of these images does. So first, let's get started. I hope you can see my laser, which will help me explain it to you. So once again, good morning, and I'll be explaining the fundamental processes that allows the CPU to process instructions, known as the instruction cycle. Hence, we are going to understand the instruction cycle. So first comes the first process, which is the fetch instruction. The purpose of this instruction is the CPU receives instructions from the from the memory, and then the component involved is the PC, the program counter. Now, what is the program counter? The program counter is a part of the registers that points to the next instruction to be executed. Okay, so the PC sends the memory address to fetch the instruction, and the instruction is then loaded into the instruction register. So now, in summary, in the first stage, the CPU, which is over here, retrieves the instructions from the memory. The program counter, or the PC, which you have over here and over here, identifies where the instruction is to be stored. Where the instruction is to be stored. This address is sent to the memory module, and the instruction is loaded into the instruction register. Okay, for further processing. Once the instruction is fetched, the PC updates to the next memory address. Okay, now we come to the decode stage. The decode stage. Now, the purpose of the decode stage is where the CPU interprets the fetched instruction. Now, the components involved with the decode stage are the control units, the CU, that's the short name given to it. Well, the function of the control unit is that it decodes the instructions into machine level commands. Please, I hope you're taking notes in this video. It decodes the instruction into machine level commands. Now, in this, another component involved is the opcodes and operands, where the instructions is split into opcodes, where the opcode specifies the operation like addition or memory access, and the operand specifies the data or memory location involved, which is in the diagram. I hope you can all see this. Now, the CU, which is the control unit, reads the instruction register to understand the required operation, breaks down the instruction into smaller steps called micro operations. So, in summary, next the CPU moves to the decode stage where the instruction is interpreted. The control unit examines the instruction in the instruction register and identifies the operation to perform called the opcode, and the data or address involves called operand. The result of this stage is set of commands for execution. Then we come to the execute stage, where the components involved is the arithmetic and logic unit. Now, the role of the arithmetic and logic unit is to perform uh, arithmetic and logic calculations or operations. And then another component needed is the memory registers. Now, in the execution stage, a CPU carries out the operation specified in the instruction, which is over here, the instructions which have come along over here. For example, if it's an arithmetic operation, the ALU or the arithmetic logic operation unit processes the data. If the instruction requires accessing memory, then the CPU reads or writes the memory model. Finally, for branch instructions, the program counter, sorry, the program counter is updated to a new location. So we have a summary, the instruction cycle. Let's recap. So now let's come to the fetch. The fetch retrieves the instructions from the memory, and the decode operation interprets the instructions into commands, and the execute perform the operations and update components. So this is the diagram highlighting the stages. So to summarize, the fetch, decode, execution cycle, also known as the instruction cycle or the data cycle, is the backbone of a CPU's operation. It starts with fetching the instructions from memory, decoding it to understand what needs to be done, and executing it to perform the desired tasks. This process repeats for every instruction, enabling the CPU to function properly. Well, we have come to the end of our lesson, so thank you for watching and have a great day.